scenario. The graph shows represents the net torque due to the surface exerting a frictional force on a wheel as a function of time from 0 seconds to 8 seconds as the wheel turns around its central axle of rotation. First question. What is the change in the angular momentum for the first 3 seconds? The change in angular momentum can also be seen as the angular impulse. The angular impulse here is the area under the net torque versus time graph. So for the first 3 seconds, you would have to look at the area for the first 3 seconds. And it looks like a triangle. So we can do 1/2 base, which is the time, times the height, which is the net torque. That's how I got 1/2 torque net times delta t. We can plug in the values here, 3 seconds and 8 newtons for the net torque, 1/2 because this is the shape of a triangle. Then we get a value of 1.2 kilograms times meter squared divided by seconds. That is the unit for the angular impulse. Next, how is the change in the angular momentum different at the last 3 seconds than the first 3 seconds? Well, let's calculate the last 3 seconds. What's that angular impulse there? So the area under the net torque versus time graph is the angular impulse, like what we said before. But this time it is a rectangle because it looks at the last 3 seconds. So it was 1 second, 2 seconds, 3 seconds. So we're looking at this area. Okay? And that would be around, the height is around 6.0, is around 0.65 newtons, and the time here is 3. We multiply that, it becomes 1.95 kilograms times meter squared second. Okay, the change in the angular momentum here is greater because this is 1.95 and before it was 1.2. This leads us to the last question. Why is the change in the angular momentum greater in the last 3 seconds than it is for the first 3 seconds? When at the end the final torque was 0.65 newtons, but the torque for the last 3 seconds was 0.8 newtons. So this is the 0.8 newtons, and this is the 0.65 newtons here. Okay. So why does this have a greater, why this is lower if this number is supposed to be higher? The reason why is because the net torque in the end was constant. It was a constant 0.65. But here, the 0.8, that wasn't constant. It was increasing up to 0.8 newtons, where the last 3 seconds was a constant value of 0.65. That is the reason why this will have a greater torque the last 3 seconds. So the torque for the last 3 seconds, the angular impulse for the last 3 seconds is greater than the impulse for the first 3 seconds. So this is the first 3 seconds. Okay, even though the torque's value for the last 3 seconds is lower.